one more topic to cover in SAP 2000 for today is the output, text output, and PDF output. Output we've seen already for the PDF for the member design. So all you have to do is right click on it after you do the design and pop up a member design, and you save that basically to a PDF, and you name it as whatever it is. Whatever is beam is a beam, is a column is a column, and I typically just say click on it, right click on it, open detail, and then there's the option for you to print to PDF. Yeah. So print each member, yeah, and then compile it as your member, yeah, and then you should put that behind the overall SAP design or the general, yeah, this one you're showing. Okay, yeah, print it on each member and then attach it to that, and then package that as your member design, because we're actually using SAP for the design. Yeah. As if they're doing it correctly or not, I'll have to check it. I mean, probably we might be doing some small assumptions that each of us have different, but I know the Excel is doing correctly. The member, the fluxure should be correctly what I checked it before. So just didn't match. We just, yeah, print it this way, add your SAP design for member, yeah, then you do that. You could say whatever engineer, whatever type, your B9, and just this is the output. And then the DCR, when we do the DCR, you could fill in this is your DCR for the member design 0.39. So that's it for the PDF output part of it. Now if you want to do output the reaction to engineers for their own design of the foundation, then we'll just select the two nodes and then display, show table, and then go to the joint output. We want the reaction, okay, and I want it all, okay, and in all cases, if you want, yep, okay, and then you could save it first and then come back, but no, you don't. So I just do it this way and I export it to Excel. Okay, you probably do the same thing. So now you have a design that's basically D through E. It should be L1 to 7, right? So if you want to show this, you could. They give you a max and min. You could just print it this way and then show it. Look at the joint. I typically format it so you could print one page per joint. So if you go to view, page layout, where's view, page layout, and if I could get it to one sheet, that would be good, but then there is all these ones I didn't want to show before. So you could show it or you don't, then hopefully that will be cover it in. You could do one sheet or two sheets if you want. Then I'll put this, and if the engineer wants to see it, then they could see the output. So if you want to make it, okay, let's make it 2 sheets and go to this way, and 2 sheets per node. That might be easier to read. Then just format it this way and show it. Let's see how this reads. Okay, so node, I would probably separate it at 35. So these are all basically combos, and 36 to 64 is RFD combos. So if you go back to the home, separate if you want, say 35, 36 to 64 is RFD. It might be different, but these are the combos. And what I typically do is you put a sheet, you want to repeat the rows on the top. Okay, How come it's not doing it? Oh. So go page setup, sheet, repeat rows on the top. I want to see the heading, and okay. So now when you go to print, each sheet's got the same heading on the top, so it's easy to read. So now you join. So this again, print it to PDF and label it as your give it a project name something, right, and blah 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 base reactions, and then by date. Okay, and then on the bottom you could do up to you. You want to put a date or path or whatever you want to do. Previously they won't allow the path, but now they allow the path. So I don't know how you guys keep track of it, but you know, you could do page number of pages if you want to see it, 1 of 4, then that's fine. Okay, so that would be the option. I typically like to see the grids on it so you could read across better. So, and horizontal, center it horizontally. Vertically, you don't want to center, it looks kind of odd for sheets, but you want to see the grid lines. So that's the output, right? You guys know this?
Yeah.
No? You haven't used Excel much.
Format in the sys, not in
Oh. Yeah. So yeah, whoever does yours is do formatting should be. So now if people want to look at it, then they know here are my 3.36 dead low LC1, 3.36 combine it together. If they want to check it, then that's their total dead low. Yeah. If they want to look at it, this we include this is because engineers wants to do their design. They want to look at, okay, what's my maximum axial, maximum shear. Here is not evident. You might want to tell them that, or have a legend somewhere. What is X? What is F1, F2, F3? Yeah. We know it in SAP. When somebody looks at a number, they don't know what it is, right? We know that when you look at a dead low, that is the dead low. So it should be F3. F3 is going up and down. So if we go back and check the dead low, okay. Yeah, so that should be the left 2 no 3.306. That's shear. Okay, 1 shear, 2. So the 2 direction all should be 0. If you can see it, they're so close. Negative 18. So all these values in the 2 is 0. So all your concern is 1 and 2. 1 is the X direction, 3 is the Y direction. So, and okay, look at it. What about the what's the sign direction? What's tension? What's compression? So if you look at it, just the dead low is pretty easy to see. Compression for node 2. If you look at the let's say LC7, it's negative 18. Okay, negative 18. What is 7? I always go back to the seismic one because it's a good way to see how your structure. If you push it this way, right? This side better be in compression. This side better in tension. So you look at the numbers, then no negative is in tension, positive is in compression. So when you look at this one, negatives in tension, and go to this side, positive is in compression. Okay, so this is what we need to print out again, the PDF. And what I do is in this one, you know how to print as a PDF. One good thing in Microsoft now, you save and send, and then create a PDF document. So you don't have to go print anymore. You just say save and send, create PDF document, create and put in the desktop base reactions. Okay, and it does PDF for you.
We don't provide the graphics with the F1, F2, 3, 4, anything.
When you print out this thing here, it doesn't show it because typically I'll show you what a package looks like next week. We show the node number. Well, we want a section. We want a node label, right? So these is what you see. Graphically, SAP doesn't really display what's local through axis.
Sure.
They only show you X and Y, so it's kind of hard to see which one's local, one direction or three directions. So make sure when you mention it that this one is this is two and
it's either one, 2, 3.
Yeah, that's right. X is one, so 1, 2, 3. Yeah, positive this way, positive that way, positive that way. 1, 2, 3. So that's the right hand rule. So yeah, so that's the output for pretty much the output. That's all you need for the engineer to do their own foundation design, and then all your output for your own design to package it. So we still put that in the package. Okay, and I'll show you what a package looks like next time that has all that. At the end, when we communicate with either the engineer record or the architect, they actually like to see what the frame looks like in AutoCAD or in Rivet or Tekla, however we want to do. We should show that as a last page so they could check and make sure the dimensions is what they're getting. So the package introduction, some comments, and all the analysis and design and member design, connection design, base plate design, anchors design, and then follow by your base or your frame elevation, and you package that. That's the package that goes to your branch engineer. Branch engineer reviews it. They send it to the engineer architect for review. So I'll cover some of this lightly, but most of these I'll be going over in the calculation package content, and we should create a checklist of what to send back and forward and what they should check on that. So that's pretty much the analysis, design, and output for SAP. So we're in good, made a lot of good progress all week. There's a lot to learn. And then the next Friday, I'll actually show you how to model our SMF. Okay, the how to model the connection tomorrow, and what's the pushover analysis, what's how SAP, all the different materials they have to model the different behavior for nonlinear analysis. So that will be tomorrow for the 5.1 to 5.3. It wouldn't be too long for the 5.1, 5.2, 5.3. I'll show you guys how and what we use it for. Okay, I think that's it, and I'm going to go